Okay, so I'm going to be doing illustration number 19 in your textbook to again give you some more illustrations on how to get z-values and how to look those areas up under the curve. So for part A, I'm going to put this right up over here. I'm going to go ahead and draw my curve. I'm going to put the 3,000 in the middle, and then just to remind you that the sigma value is 450. So they want us to figure out the percent of refunds that are more than 3,100. So I'm going to write 3,100 just above the mean. I'm going to draw my line, and just to kind of represent the or shade the area that they want you to find is to the right of 3,100. So it's the upper part of the curve. So I first have to get a z-value. So you would take 3,100 minus the mean of 3,000, divide that by 450, and that's going to give you a z-value that's right about 0.22. So, and also do the z-value for 3,000, which is also 0 because you're right in the middle. So I got between 0, I got a 0.22 right there. But again, I want to find to the right of the 0.22. So if I go down here to my probability table, your probability table gives you everything from 0 up to whatever particular z-value you're looking for. So let me draw another line just to kind of show you what I'm going to find here. So if I go to 0.2 on your table, there's your z, and then go to where it intersects with 0.22, there's your hundredths at the top. The area says is 0.0871. So guys, this area right there is defined as 0.0871. The table says that's from 0 up to 0.22. So if I want the rest of this half of the curve, what I basically just have to do is to subtract that from 50% to fill in the rest of the half. And that's going to give me 0.4129, which is your answer. So 0.4129 would then give you the rest of the curve. That's basically 41.29%. Now, part B, same thing, but they're going to ask you between two different values. So I'm going to go ahead and draw my curve again. We've got 3,000, and we want between 3,100, which we've already looked up, and 3,500, which we have to get a different z-value for that one. So if I draw my lines, shade my area, we want to find that particular area. So if I were to get the z-value for 3,500, that's going to be 3,500 minus 3,000, divide that by 450, and that's going to give me a z-value that's right at about 1.11. So if I go to my table, I look up 1.1, and then there's 1.11, I get 0.3665. And I already know the z-value for 3,100, which was 0.22. So let me write these right down here just to remind you. That was 0.22. That's 1.11. If I look up this area, we already did. We said it was 0.0871. Okay. And remember, by default, in the middle of the curve right there, that's 0. Both of these areas take you back to 0. So because basically we want to intersect, where they intersect is at this data point because the table both goes to the left. To get what's in the middle, we basically subtract, and your answer is going to be, it looks like it's 0.2794, would give you that area basically in the middle between these two areas. All right, so that would be letter B. Now, last one, letter C, does it again, says we want more than 2,250 but less than 3,500. So lastly, I'm going to draw my curve again. We know 3,000 is my starting point in the middle. I know that 2,250 is in the lower part of the curve, and that 3,500 is in the upper part of the curve. And so we're wanting to find that particular area. So we got to get the z-scores. We already did it for 3,500. We said it was 1.11. If you did it for 2,250, you take 2,250 minus the 3,000, divide that by 450, and that would give you a negative 1.67 z-value. So I'm going to put that right there. So now I go to my table, and remember, whether you got positive or negative z-values, just use the absolute number in these tables, and you'll still get the same area. So we already knew that when we looked up 1.11, that area was 0.3665, and so let me draw a line right here. What that basically means is from 1.11 all the way down to 0 is defined as 0.3665. So if I can find 1.67 to 0, I can add these together to get my answer. So if I find 1.6, which is right there, and 1.67 0.7, which it looks like it is going to be 0.4525. That would be right there. So now I just have to add them together. So take 0.3665, add 0.4525, and that'll be your cumulative probability, and you'd get right at 0.8190 is basically your answer. So essentially, this is a half probability table, and we were basically looking at two halves of the curve. Once we found these areas, we just combined them to get the final answer.